Hello class, I'm glad you could join me for today's lesson. We're looking at Unit 8, Lesson 1. So please find the appropriate packet from all your work and we'll get started. First, what I want to do is a warm-up. So we have lists of numbers here, and what we're trying to find is a pattern. How do I get from 5 to -6? And how do I go from -6 to -17? And on this next one, how do I go from 8 to 16? How do I go from 16 to 24? So I encourage you to take a minute, try to find any patterns in the numbers, and then we'll meet back together in the video. So for number 1, we are asking ourselves, how do we get from 5 to -6? If I have 5, and let's say I add a number, and that gets me to -6. Well, what is that number? If we add -11 to 5, that gets us -6. You can also think of it this way. That's like saying 5 minus 11 is -6. But I'm always trying to think about addition here. So 5 minus 11 is the same exact thing as 5 add -11. All right, let's see if this pattern holds up. So if I do -6 and I add -11, my result is -17, which is the next number in my list. It seems to be working out. So if I do -17 and I add -11, I should get -28, and hey, that's the next item in our list. So here is the pattern that we see. We can always add -11 to get to the next number. So we see this pattern continuing. I'm always going to add -11 to get to the next number. Yes, we could say this is subtracting 11, but for these problems, I want to think about it as addition. Okay, number 2. How do we go from 8 to 16? So right away, I see if I do 8 and I add 8, I get 16. Let's see if that pattern continues. So let's do 16 plus 8. We use our calculator. That gets us 24. So that seems to make the pattern match our list here. So 24 plus 8, we do some calculation. That's 32. All right, so we found the pattern that makes this list work. As long as we're adding 8, we can always find the next number. So that's our pattern here. We add 8. Okay, next one. How do I go from -8 to 2? So if I do -8 and I add 10, that will get me to 2. Let's see if that pattern keeps going. 2 plus 10 is 12, but that doesn't match with my list here, so something's wrong. So sometimes we're going to see things that we have to multiply to get to the next number. So let's try that. I have -8 and I'm trying to get to 2. So there's a number that when we multiply it by -8, we get +2. If we don't know what that number is, we can use algebra. Let's use some division here to figure it out. So x equals 2 over -8. Let's simplify that a little bit. Divide the top and bottom by 2, so we get -1/4. Okay, let's see if this pattern works out. So if we have -8 and we multiply it by -1/4, 2 negatives make positive, so that's +8 over 4, which is 2. That's what we wanted. Let's keep going. If we take the 2 and multiply it by -1 over 4, well, that's -2/4, which is -1/2, which is -0.5. All right, this looks to be the way that we continue our pattern. If If we do one more, so negative 0.5 times negative 1 over 4, we should get in our calculator positive 0.125. So that's what's happening here. Every time we are multiplying by negative 1/4 to get to our next number. So multiply by negative 1/4, multiply by negative 1/4. Okay, so I'm always looking out for these types of patterns. You keep doing the same addition to get to the next number, or like in this case, we keep multiplying by the same number to get to the next number. Okay, number 4. How do I go from negative 6 to 3? Well, if I do negative 6 and I add some number I don't know, that will get me to 3. So I can just use algebra to solve for x. I get x equals 9. So negative 6 plus 9, yeah, that gets us 3. 3 plus 9, that gets us 12. 12 plus 9, that's 21. So we figured out the pattern here. Every time we're going to add 9 to get to the next number, so add 9. Oh, and I think for the last problem I forgot to say our final answer, multiply by negative 1/4. All right, let's keep going with this. So our warm-up here was to help us with something called sequences. A sequence is a set of numbers in a particular order or pattern. So just like we saw in the warm-up. There's two kinds of sequences. There can be an arithmetic sequence or a geometric sequence. In an arithmetic sequence, all you have to remember is you add to get to the next number, and a geometric sequence means you multiply to get to the next number. So an arithmetic sequence, each term, and a term is just a number, so each number, each term is determined by adding a constant value to the previous term. So we're always adding the same number to get to the next number. That value is called the common difference. Common difference. And a lot of the times we'll see that represented by D. So if I go back to the warm-up, if I'm always adding negative 11, that means my common difference, D, is negative 11. On the second example, if I'm always adding 8, my common difference is 8. Okay, in a geometric sequence, each term is determined by multiplying a constant by the previous term. And that constant is called the common ratio. We'll see that represented by R. Okay, once again, if we go back to our warm-up, for the third example, if we're always multiplying by negative 1/4, that means our common ratio, our R value, is negative 1/4. And just for good measure, this last one, the common difference, if we're adding 9, is 9. Okay, so for all of these examples, we're going to determine whether they're arithmetic or geometric, and then we want to find the appropriate common differences and ratios. Okay, first example here, we want to see how we get from one number to the next. So how do I get from 23 to 17? So if I do 23 plus some number I don't know yet to get to 17, can use some algebra to figure that out. So we see x is negative 6. So if I do 23 plus negative 6, that gets me 17. If I do 17 plus negative 6, well, that gets me 11. 11 plus negative 6, That gets me 5. And that is my pattern that I was seeing. So this is correct. We know we always have to add -6 to get to the next number. If it's addition, we know it has to be an arithmetic sequence. So let's write that out. This has to be an arithmetic sequence because it's addition. What are we adding every time? Well, we're always adding -6. So our common difference is -6. Let's try another one. So how do I go from 8 to 2? I know that I can do 8 plus -6, but then if I do 2 plus -6, well, that doesn't get me 1/2. So I know something's wrong here. So I always want to eliminate the arithmetic option first. If I know it's not arithmetic, then it has to be geometric. So we're multiplying something to get to 2. So 8 times some number we don't know yet is equal to 2. We can divide both sides to find x is 1/4. So 8 times 1/4, that is 8/4, which is 2. 2 times 1/4, that's 2/4, which is 1/2. 1/2 times 1/4 is 1/8. So that's the pattern we see in our list here. We multiply by 1/4, multiply by 1/4, multiply by 1/4. Since we're multiplying, we know that this has to be a geometric sequence. And a geometric sequence has a common ratio. So we know we're always multiplying by 1/4. So that is our common ratio. Let's try one more. So how do we get from 16 to 24? First thing I want to do is check whether or not this is arithmetic. So if I do 16 plus some number is 24, we find out that that number is 8. So 16 plus 8 gets me 24. 24 plus 8, that gets me 32. But hold on. I should have gotten 32 right here, but I got 36. So that tells me this is not arithmetic. We're not adding. It has to be geometric. So let's try that again. 16 times some number, I don't know yet, is 24. Trying to find out that number, and I get that this is 24/16, which is 3/2, which is 1.5. Okay, we can verify this with our calculator. 16 times 1.5, that's 24. 24 times 1.5, that gets us 36. 36 times 1.5, that's 54. So we see the pattern here. We're always multiplying by 1.5. So we can say that this is a geometric sequence since we're multiplying, and our common ratio is 1.5 because that's what we multiply by. Alright, I'd like you guys to try D and E on your own, then come back to the video to check your answer. Okay, part D, I'm trying to determine how I can go from one number to the next. So let's try to see if this is arithmetic. If I add 1, I get 2. If I add 1 again, I don't get 4. So that's out. It has to be geometric. So 1 times another number is 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So every time I found out that I'm multiplying by 2 to get to the next number. Because I'm multiplying, it has to be geometric, and my common ratio is 2 because that's the number I'm multiplying by. Next one, we have 22, 36. So 22 plus a number we don't know yet. We can subtract 22. We get x is 14. Let's see if that works. 22 plus 14, that's 36. We're using our calculators here. 36 plus 14 is 50. 50 plus 14, that's 64. And that matches our pattern. So we know for sure to get to the next number, we just have to add 14. When we're adding, that's called an arithmetic sequence. So we'll write that out. It's arithmetic. Our common difference is 14 because we're adding 14 every time. Okay. The reason this is useful is that we want to be able to find any term in a list. So if I go back here, we see this dot, dot, dot. This list keeps going on forever. I can keep adding on 14 over and over again. But what if I wanted to know the 20th number in the list? What is it? Or what if I wanted to know the 61st number in the list? It would be kind of tedious to just keep adding 14. There's an easier and quicker way to do it. And it's given by an arithmetic sequence formula like this. So when we're talking about the nth term, n is just any number. So like I said, it could be the 40th term, could be the 8th term. Whatever term we're looking for, that is our n value. So an, that is the nth term. It's what the problem's going to be asking for, like find the 8th term, find the 10th term. A1 is our first term. So what is the first number in our list? N, that's just whatever number n is over here. And D, that is the common difference, or it's what we're adding every time to get to the next number. The problem tells us the first term of the sequence is 18, and the second term is 16. So we're going to start our list with 18, and then we're going to go to 16, and then the list keeps going from there. So this is an arithmetic sequence. We want to find out what number are we adding every time. So I know right here, if I add negative 2 to 18, that gets me 16. So let's start to put this stuff together. In order to fill in my equation, or my formula, I need to have an, a sub 1, plus n minus 1 times d. So what is a sub 1? A sub 1 is our first term that was given to us. We know it's 18. And then here in the problem, we're told that we want to find the 6th term. So n is 6. And our nth term, our 6th term, that's a sub 6. And d, our common difference, is negative 2. So we can start to assemble this into our equation. A sub n is a sub 6, because that's the number we're trying to find out. A sub 1 is 18, because that's our first term. We're adding n minus 1. N is 6, so it's 6 minus 1, times d, which is negative 2. So 18 plus 5 times negative 2, so that's 18 plus negative 10, so 8. So what we just discovered here is a sub 6 is 8, where a sub 6 is the 6th term. And let's verify this, because we could totally do the math on here. We're starting with 18, the next one is 16, we're always subtracting 2. We have 14, 12, 10, and 8. So this is the first term, second term, third term, fourth term, fifth term, sixth term. Exactly what we found using our formula. We can do the same thing with a geometric sequence. So just like we saw with our arithmetic sequence, A sub n is our nth term. So the problem's going to tell us what n is. We just have to figure it out. It's what we want to know. A sub 1 is our first term. R, we know that that has to be our common ratio. It's what we multiply by every time. And then n, it goes with what the problem tells you. Okay, the first term of our geometric sequence is 18, and the second term is 16. But we know this has to be a geometric sequence, so instead of addition, we're doing multiplication. So 18 times what number gets me 16? So we can do the math on here, divide both sides by 18. So we get about, let's just estimate this, 0.9. That's the number we're multiplying every time. So 18 multiplied by 0.9 gets us 16, and we can keep that pattern going. But we want to know the 8th term. So I'm trying to find out the 8th term. A sub 8 means the 8th one. It's going to equal the first term, 18, multiplied by the common ratio, 0.9, and that's raised to the n minus 1 power, so 8 minus 1. So 18 times 0.9 to the 7th power. Once again, we can estimate this is about 8.6. So if I kept continuing this pattern, by the time I got to the 8th number, it would be about 8.6. Okay, let's do an example with this. So the population of my town is 2,400 people in the year 2007. So from 2007 to 2010, the population increased by 5% per year. So what's the population in 2010? Okay, the first year that we're keeping track of things is the year 2007. So that's my first year. And we have 2,400 people. So then we have 2008 is the second year, 2009 is the third year, and 2010 is the fourth year. So really, what I'm asked to find is that fourth term. This is what the problem is asking. What is the fourth term? So I have my population, and it keeps increasing. I want to find the population in that fourth year. Okay, if the population in my town increases by 5% per year, well, if I had my original population, 2,400 people, and it stayed the same the next year, we could multiply by 100%. 100% is the same thing as multiplying by 1, because if we move that decimal, we get 1, and it stays the same. But our population is not staying the same. It is increasing. So what if we called this 105%? So that's 2,400 multiplied by, we move that decimal place twice to turn it into a decimal, we get 1.05. So this 105%, that means we take our same population and then add another 5% on top of it. we want it in the decimal form like this. So that is our common ratio. It's what we're multiplying by every time. That's our R value. All right, let's put this together. We're trying to find the fourth term. So I want to find A sub 4. My initial A sub 1 is 2,400 people. I then multiply that by my common ratio, 1.05, and we can raise that to the n minus 1 power. So 4 minus 1. So that's 2,400 times 1.05 to the third power. We do a little bit of math on that, and we get about 2,778 people. If you got a decimal on your calculator, make sure that you round it because we're talking about people. We can't have, a decimal of a person. Okay, let's transition to something else. So far we've been working with sequences. Now we're going to do a series. So a series is just when you take all of the numbers, all of the terms in a sequence, and add them up. So an example of that would be if I went back here and I took every number in this sequence and added it up. So 8 plus 16 plus 24 plus 32, and I keep going. All right, an arithmetic series is the sum of an arithmetic sequence. And the sum of the first n terms is called a partial sum, and we write it as S sub n. So S sub n is the sum of the first m terms. A sub 1, that's still going to be our first term. A sub n, that's the term in the sequence. And then we're dividing that by 2. So let's see an example of this. I'm given the terms in a sequence from the first term all the way to the 24th term. And I want to add up all of those numbers. So it'd be tedious to do that all in your calculator, adding up all those numbers. Or you could just use this formula to figure it out. So we want to find the sum of the first 24 terms. So that means I'm looking for the sum. So S sub 24. N we can write as 24. We put our parentheses. Our first term here is 1. And the 24th term in our sequence is 108. So basically, what's the first and the last term in the sequence you're looking at? And then you divide it by 2. So we have 24 times 109 over 2. We do a little bit of calculation on that. That's 24 times 54.5. And we get 1,308. So if I added all 24 of these numbers up, when I add them together, I get 1,308. Okay, let's try another one. An arithmetic series has 6 terms. The first one is -9. Then I have the other ones, and the last one's 9. So really, we just need to know the first and the last term. We want to find the sum. So the sum of the 6 terms, that is going to be n. N is 6. The first term plus the last term divided by 2. So that's 6 times 0 over 2, which is 6 times 0, which is 0. So when I added up all these numbers in here, I don't even have to know what the numbers are. I know when I add them all together, I get 0. Okay, let's try this last one on the bottom here. We want to sum up the numbers from 1 to 50. And there's some numbers in here that we don't know. So I'd like you to set this problem up, solve it on your own, and then check back with the video to see if you're right. Okay, This is my first term. I'm assuming this is my 50th term. So S of 50, that's going to be 50 times the first plus the last divided by 2. So 50 over 51 over 2. So that's 50 times 25.5, which is 1,275. So if I add up all the numbers from 1 to 50, that's my total. Okay, we can do the same thing with the geometric series. Our formula is just going to look a little bit different. So once again, this is the sum of the first n terms. Our first term, r is our common ratio, and we just need to plug in all the information we get from our problem. Okay, we want to find the sum of the first 8 terms. So right away, that tells me we're looking for S sub 8. A1, that is our first term. We see that it's 4. And then, so we do our first term minus our first term again, but this time multiplied by the common ratio. So our common ratio, 4 times some number equals 1. So our common ratio is 1/4. 4 times 1/4 is 1. 1 times 1/4 is 1/4, and so on. And then that is raised to the n power. We know n is 8. We can divide. We do 1 minus that common ratio. And we just throw all of this into our calculator. If you want, you can turn that fraction of 1/4 into a decimal, 0.25. It might make it a bit easier. Here's how I would do it. So let's go over to Desmos. Okay, so 4 minus 4 times the 0.25, and that 0.25 is raised the 8th power. And then we have 1 minus 0.25. So we get about 5.3. I'm going to round that. So about 5.3. So if this keeps going, if I do 4 plus 1 plus 1/4 plus 1/16, that keeps going, by the time we do 8 of them, we're going to get about 5.3. Okay, let's try another example. So this person has deposited money into their bank in July. So from July to December, the amount of money increases by 25%. So what's the total amount of money in the account after December? Okay, let's call July the first month. Then we have August, September, October, November, and December. So December ends up being the 6th month. So we're trying to find the total amount of money after December. If December is the 6th term, I'm trying to find S sub 6, the sum of the 6 terms. Okay, A sub 1, that's our initial amount of money, is $850. And then our common ratio, so if I took that $850 and multiplied it by 100%, the next month I would still have $850. But we are trying to increase the amount of money by 25%. So if we call that 125%, it's going to increase the amount of money I have. We can turn that into a decimal. So every time we're going to be multiplying by 1.25. So that's my common ratio, 1.25. And we raise that to the nth power. N is 6 here. And we want to divide it by 1 minus the ratio. Okay, let's throw this into our calculator. And we should get about $9,570. Okay, I'd like you guys to try this one on your own and then check back with the video to see your answer. Okay. On the first day, a website got 4,000 page views, and during the next 4 days, page views increased by 30% every day. So our common ratio is 130% turned into a decimal, so that's 1.3. So what's the total amount of page views in the first 5 days? This is what we're trying to find. So S sub 5, we want the sum from the first 5 days. A sub 1, that's our initial amount of views. Our common ratio is 1.3, N is 5, and we have 1 minus 1.3. We throw that into our calculator, and we get the result of about 36,172 views. And again, if you have a decimal, we can't have like a part of a view. You either watch the video or you don't, so let's make it a whole number. Okay, I'd like you guys to try one more. So give this problem a try and then come back to the video. Okay, in 1995, box office revenue was about 5.02 billion. And then from 1995 through 2008, the revenue increased by 5.9% every year. So if we're increasing, we're going to take 100% and add in that 5.9%. So we get 105.9%. We want to turn that back into a decimal, so our R value is 1.059. So we want to find the sum of the money from 1995 to 2008. Okay, so if 1995 is my first year, so 2008 is the 14th year. Let's start filling stuff in. Our initial amount is the $5.02 billion. And then our ratio, like we found, was 1.059, and that's raised to the 14th power. We're going to divide by 1 minus 1.059. And our answer, we should get about 105. But we're talking about billions of dollars here, so it's 105 billion. Okay, let's wrap this up just by going over our formulas again. So we have our arithmetic sequence. So that's the first one we saw. A sub n equals A sub 1 plus n minus 1 times d. And let's, off to the side, let's make a note of what all this means. A sub n is our nth term. A sub 1 is the first term. And d is the common difference. So it's whatever you are adding to get to the next number. We have a sub n is equal to a sub 1 times r to the n minus 1 power. And it uses all the same vocabulary as the last one. Okay, for our series is denoted with an S, so the sum of the first n terms is given by S of n. Then we have multiplied by n, a sub 1 plus a sub n over 2. And lastly, we have our geometric series. So S of n is equal to a1 minus a1 times r to the nth power, and we have 1 minus r. Oh, and I almost forgot this. R is our common ratio. So it's what you multiply by to get to the next number.